welcome to Mogojastro. Today in this session we are going to discuss about the fifth part of the organic chemistry, that is the homologous series and the nomenclature. So let us start with the homologous series. We have to know a little bit about the homologous series. That is, the homologous series is a group of organic compound having a similar structure and similar chemical property in which the successive compound differs by a CH2 group. It means that any alkane is added with CH2 group, it becomes another alkane which have similar structure and similar chemical property. Similar chemical property. It means that if by adding CH2 group, by adding CH2, okay, let take CH4, it is nothing but the methane. You add CH2, it become C2H6. So what is the structure? What is the structure of the CH4? It is a carbon is surrounded by a single bond, that is the carbon and 4 hydrogen are present in their neighboring atom. This is the structure of the methane. Now what is the structure of the ethane? This is ethane because 2 carbons are there. So carbon structure of ethane is like this. So all neighboring atom of carbon are attached with hydrogen by a single covalent bond, and the bond between these 2 carbon is also a single bond. So they have the similar structure. Why they have similar structure? Because they are surrounded by a single covalent bond. Okay. So the structural formula is CnH2n plus 2. Because this is the structural formula of the alkane. Here, if you notice, then this has also satisfy CnH2n plus 2 structural formula. So general structure or both are same. So also by removing, so here you notice one thing, that by adding a CH2 in a given hydrocarbon, we got another hydrocarbon C2H6, and it is a higher number. It has a higher number of carbon present in this group. So we are getting the higher number of carbon by adding a CH2 group with the previous one. Okay. Similarly, by removing one CH2, what happened? If you take butane C4H10, then remove one CH2, it becomes what? C3H8. Obviously these 2 hydrocarbons have the same similar structure because they all are structured by a single covalent bond, and their general structure, as it is a alkane, so general structure is CnH2n plus 2. Okay. So what are the characteristics of the homologous series? The characteristics of homologous series is that each member of the series differ from the preceding ones by the adding a CH2 group and the increase by the molecular mass of 14 AMU. It means that this one is the preceding one. So if you add one CH2, then we get this hydrocarbon. And what is the difference between these 2 hydrocarbon? The difference between 2 hydrocarbon is we are getting 1 carbon and 2 hydrogen more. It means that the molecular mass of this product is higher by 14 AMU. Why 14 AMU? Here we adding CH2. What is the molecular mass of carbon? Carbon is 12. What is the molecular mass of hydrogen? Hydrogen is 1. So it becomes 12 plus 2 into 1. 2 hydrogen are present. It is 14 AMU. Okay. It is increased by AMU. Eventually, if we remove the CH2, then the molecular mass becomes 14 AMU less than the preceding one. Second one is all members of the homologous series share a general formula, that is the CnH2n plus 2 of the alkane. Of the homologous series of the alkane, if you consider alkane, then it becomes CnH2n plus 2. If you consider alkene, it becomes CnH2n. CnH2n. It is for alkene. So the homologous series of alkene becomes CnH2n, and homologous series for alkane is CnH2n plus 2. So if you add CH2 with alkane or alkene, it becomes CnH2n plus 2 or Cn plus CnH2n, and thus their structure is also same, that is they have either governed by the single bond or by the double bond. Okay. Now the physical property of member is changes. Why? Because you know that molar mass, that is the molecular mass, is changes by 14 AMU. So the gradually as you added up the CH2 with methane, then methane become ethane become propane become butane become pentane, like this. So for that, every addition of CH2, there is an enhancement of 14 AMU of the molar mass. So for that, if we know that if molar mass is increased, then the melting point, boiling point, density of the successive members is also, homologous series is also increased with the increase of the molar mass. If so, molar mass is increased, then density, boiling point, melting point is also increased with the successive members of the homologous series. So these are the very basic property of the organic of the homologous series. Now we can consider one thing, that is methane, then ethane, then propane, then butane. You can take other also. So what is the molecular mass of this? Molar mass, if you give a heading molar mass, it is the CH4, that is the 16, 12 plus 4, then increase by 14, that is the 30, then again increase by 40, that is the 14, that is the 44, then increase by 14, that is the 58. In this way the molar mass is increases. Okay. Now what is about the boiling point? The boiling point become, for methane it becomes minus 161.4 degrees centigrade. Here for ethane it becomes minus 88.3 degrees centigrade. Propane it becomes minus 44.5 degrees centigrade, and for butane it becomes 0 degrees centigrade. Okay. And the physical state, what is about the physical state? The physical state is changes like, for methane it is a gas, for ethane it is also a gas, for propane it is also a gas, but for butane it is also a gas. If butane is used in our LPG, and if you consider pentane, then the molar mass is 58 plus 14 is equal to 72. 8 plus 4 12, 72. The boiling point, I think it is 36.2 degrees centigrade, and it becomes liquid. So if you increase pentane, then hexane, then septane, then octane, then nonane, then decane, then it becomes transferred from liquid to solid. Okay. So changes in the molar mass, the boiling point is also changes, and the physical state is also changes. Okay. Now you know the example of the homologous series you can find easily, that is the alkane, alkene, alkyne, and alcohol. Okay, you take 4 things. So methane, it is CH4, then ethane is C2H6, then propane is C3H8, then butane is C4H10, like this. Okay. According to the methane, according to that, if you write the alkene, why I am not considering CH2, that I will tell after some time. So ethene is C2H4, then propene C3H6, then butene C4H8, then pentene C5H10, like this. Okay, so now if you consider the alkyne, there is the ethyne, there is the C2H2, propyne C3H3H4, then butane C4H6, then pentine C5H8. So general structure of alkane group is CnH2n plus 2. Okay, the general structure of the alkane is CnH2n. The general structure formula of alkyne is CnH2n minus 2. And what is about alcohol? Alcohol is nothing but the Cn, very important for your class 11 standard chemistry, that is the CnH2n plus 1 and OH is associated with it, because you know that when OH is there, then you can say it is a alcohol. And why it is a CnH2n plus 1, why it is not CnH2n plus 2? Because it loses, if this alkane loses one hydrogen, then it becomes alkane, loses one hydrogen, it becomes alkyl. So alkyl, there is the methyl, there is the methanol, you can call methanol, methyl alcohol, methanol, CH3OH. Why CH3OH? Because C is 1, then H becomes 2 into 1 plus 1, that is the 3. So CH3 and OH is associated with it, so it is methanol. Like this, it is ethanol. Ethane is C2H6, so it becomes C2H5OH, ethanol or ethyl alcohol, ethyl alkyl. So like this, it is a propanol, that is the C3H7OH is the propanol. Propane become propyl if it loses one hydrogen. So propane is C3H8, it loses one hydrogen, it becomes C3H7, and then OH is associated with it, so it becomes C3H7OH. So this is the basic of the homologous series. Now you can consider the nomenclature. Okay, this is a very important topic. So what is nomenclature? You have to know what is the procedure to write any IUPAC name for any hydrocarbon or any organic compound. So nomenclature is the way how you can write that. That process is nothing but called the nomenclature. So nomenclature is the system of assignment of organic compound, of the name of the organic compound. So nomenclature is the system of assignment of the name of the organic compound. So these nomenclature, the system of nomenclature, are trivial system or IUPAC system. What you mean by IUPAC? IUPAC means, for the full form of IUPAC is International Union of Pure and Applied Chemistry. It is that in early days the name of the compounds depend on the source of the source from which we can get it. That is the for methane. Why CH4 is named as methane? it is named as methane when this is governed by the IUPAC, but previously the name of the CH4 was Mars gas, MARSH, Mars gas. Why it is Mars gas? Because we can get CH4 methane from the marshy area, that is the marshy places. Like this, acetic acid was we can get acetic acid from vinegar. Okay, so methyl alcohol. What is methyl alcohol? Methanol. CH3OH is the methyl alcohol. Okay, so here methas means the spirit, and whole alcohol, that is the whole, is nothing but the wood. So in early days the methyl alcohol was collected from the wood, often from the wood. That's why it is called the methyl alcohol or methanol. Okay, now however the nomenclature was systematized by the chemist of IUPAC in 1957. So from 1957 there is some certain change in the organic chemistry. So Mars gas become methane. So methyl alcohol, that is the methyl alcohol becomes methanol, like this. Okay, so what is the, according to the system, what is the rule of writing that name? So if you consider our name, so we have a we have the nickname. Obviously you have some nickname, that is the common name by which everybody can recognize you. So you have also another name which has a first name, a middle name, and the title of the last name. So okay, like this, every organic compound has consists of three parts. The name of the organic compound consists of three parts. One is the root word, second one is the suffix, and the third one is the prefix. Okay, like first name, middle name, and the last name. Here the three parts are root word, suffix, and prefix. So what are the root word? So root word is depend upon the number of carbon atom. So root word depend upon number of C atom. If C is equal to 1, it becomes meth. If C is equal to 2, it becomes eth. If C3, it becomes prop. If C4, it becomes but. If C5, it becomes pent. C6 becomes hex. C7, it becomes hept. If C8, it becomes oct. If C9, it becomes non. If C10, it becomes dec. Okay, so this is nothing but the root word for nomenclature, IUPAC name. Okay, this is a root word. Okay, so root word depends upon the number of carbon present. So if number of carbon is 1, it becomes, the root word becomes meth. If number of carbon becomes 6, it becomes, the root word becomes hex. If number of carbon becomes 8, it becomes oct. Now what is about the suffix? So suffix, what is the role of the suffix? So the root word is followed by an appropriate suffix, okay, which represents the nature of the bond of the carbon. That is, suffix represent the nature of carbon bond. Like if C is attached with C, single bond, then it becomes N. Okay, single bond, it becomes N. Okay, so meth, if C is 1 and there is a single bond, then it becomes meth, and as single bond is present, it becomes N. That's why CH4 becomes methane. Okay, according that, if there is a double bond, it becomes in, the suffix become in, methane. C double bond C, then H and H, C2H2. Okay, sorry, C2H4 is C2H4. You have to satisfy the valency, that is the 4 valency of the carbon. Valency of carbon is 4, you have to satisfy that. Okay, C2H4 is the ethene. Okay, ethene. Okay, now if carbon bond have triple bond, it becomes YNE, that is C triple bond C, then 2 hydrogen is there, 1 is there, another is there. It is the ethyne, 2 carbon and 2 hydrogen, C2H2, C2H2. It becomes ethyne as 1 triple bond is present. Now if you consider depending upon the single bond, alkane, alkene, alkyne, and obviously a group R with a YL group, alkyl group, alkyl. So single bond C, it becomes suffix, general name, and the general formula. So if single bond C and C, the suffix become N, the general name is alkane, and general formula is CnH2n plus 2, as single bond is present. So double bond, that is C double bond C, the suffix become in, general formula is alkene, and general formula become CnH2n. Okay, like this. If you take triple bond, it becomes C triple bond C, it becomes YNE, the general formula is alkyne, the general formula is CnH2n minus 2. Okay, like this. There is the group, that is R is present with as a bond, then the suffix is YL, the suffix is YL. Okay, like alkyl, ALKYL, alkyl. Why alkyl? Because CH2, CH4, it loses 1 hydrogen, then it becomes CH3. The structure of it is like this, and we have to satisfy the valency of carbon. So here is another covalent bond. Here that R can be attached. Okay, that R proves. So it becomes, and then as if R is OH, if R is OH, then it becomes C H H H and OH. So it becomes CH3OH. So what is the name of the CH3OH? It is the methyl alcohol. That's why METHYL, methyl alcohol. That's why it becomes alkyl group, as it loses 1 hydrogen, and in that place of hydrogen 1 group is attached with it. Then alkane become alkyl. Okay. So general formula is CnH2n plus 1, as it loses 1 hydrogen. Okay. So this is for the suffix. So what is about the prefix? So it's come into the first. Okay, so it denotes the substituents, that is the alkyl functional group and its position in the carbon chain. Okay, it means if any substituents is attached with any chain of the carbon, or any group, or any alkyl or any functional group is attached with any alkyl group, then that comes first. Okay, that name of the alkyl group, or the alkyl functional group, or the substituents come first. If you consider C like this, and 1 CH3. CH3 is the methyl group, so it is an alkyl group. Okay, it attached with carbon. So you have to write the numbering 1, 2, 3, 4, 5. How you can do this? I have to tell it after 5 minutes. That is in the next part of the video. not next part, in this video, the next continuation of the video, we can know how can you give the number. So it becomes 2-methyl. Okay, why 2-methyl? Because in the second position the group present is the methyl. This is a methyl group and it's present in the position 2. So you have to write 2 and give one hyphen, 2 give one hyphen, then methyl, then whatever the name that is depending upon the root word and the suffix. Okay, so this is all about the basics of the nomenclature. Now come to the rule of the nomenclature. What is the rule for writing the nomenclature? So first rule, in the naming of the organic compound, the following simple rules are followed. That is the selection of carbon chains. First rule is selection of carbon chains. That is the longest, that is the carbon chains means carbon has a property that is called the catenation property. By that property, a carbon-carbon chain, carbon-carbon can make themselves between a single bond, double bond or triple bond, and they make a longest chain. Almost 50,000 carbon can make a longest chain. Okay, so selection of the carbon chain, the longest continuous chain of carbon atoms known as parent chain is selected. The longest chain need not be straight. It means that we have to find the longest carbon chain. So if C, this is nothing but a carbon chain, 1, 2, 3, 4, 5 like this. Now you have another chain. This is a simple longest straight chain. There is no problem for that. If you have a chain, so C, and from here one C is present. So now which we have to consider as a longest carbon chain. So for that, if you consider this chain, so you get how many carbon? 1, 2, 3, 4, 5. Okay, now you consider another path. You consider this path. So if you consider this path, how many carbon did you get? 1, 2, 3, 4, 5, 6, 7 carbon. So we have to select the longest continuous carbon chain. So the exact carbon chain which you select is this. You have to select this carbon chain as the longest carbon chain, as in that chain the 7 carbons are present. Or you can take for that, no, here is one problem. If you erase it, then it becomes 7. So if the carbon chain is like this and here like this, then you can consider the longest carbon chain is this one, as you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons over here. Okay, so you have to select the longest carbon chain. If it is a straight chain, then it is easier to find the longest carbon chain. But if it is a branch chain, then you noticed carefully that which one, in which path you get the more carbon. In whatever the path is, you get where you get the most number of carbon, you have to select that path. Okay, now second one is the branch chain are considered to be the substituents, and their positions are indicated by the number of carbon atoms to which they are attached. It means that example which I have take earlier, in the here you connect one CH3 is there. Okay, so this is a methyl group. Okay, so this is a substituent or this is a methyl group. So you can number 1, give number 2, 3, 4, 5 like this, and then you have to put the position of the substituent or the functional group by the position, the numbering position. Here it is the 2, so you can write it 2-methyl. Okay, if you consider the next example, then you can easily got the exact funda. Okay, So third one, the carbon atom of the longest chain are numbered in such a way that alkyl groups of the substituents get the smallest possible number. So again take that previous example, CH3 is present. Now again CH3. So in which side you start numbering? You know this is a straight chain. So here the longest chain is this, because there is no branch chain, and in branch there is a group that is called methyl group. So here you can write 1, 2, 3, 4, 5, or you can, again this is the longest chain, same structure, so you can numbering like this 1, 2, 3, 4, 5. So for this, if you number like this, then the methyl it becomes 2 methyl, and if you number like this, then it becomes 4 methyl. So which you have to consider. That in the rule it is written that the carbon atoms of the longest chain are numbered in such a way that alkyl groups or substituents get the smallest possible number. Here for these two, this substituent is methyl is the substituent. For first it gets 2, position is 2, and for second its position is 4. So we have to find the smallest possible number. So in between these two, it is the smallest possible number. So you have to consider this 2 methyl is the right and 4 methyl is the wrong option. Okay, now fourth one. In case any functional group is also present in the chain, then the carbon atoms are numbered in such a way that the functional group gets the smallest possible number. What does it mean? It means that take one long example. Okay, take one long example. The example is like this, like CH3, then CH, then CH2, then CH again, then CH3, and it is, this is CH3 and here it is OH. So methyl is a substituent and OH alcohol is a functional group. So which you have to number. You can number 1, 2, 3, 4, 5, or you can number it 1, 2, 3, 4, 5. Which one is correct? You have to write, we have to determine which one is correct. For that, it is told that in case any functional group is also present in the chain, then the carbon atoms are numbered in such a way that the functional group gets the smallest possible number. This is a substituent and this is a functional group. So carbon are numbered in such a way that the functional groups gets the smallest possible number. Here functional group, if you consider 1, 2 number 1, 2, 3, 4, 5 like this, then it is, that is the, here it is, if you consider the yellow one, numbering yellow one, then it is 2 methyl pentan 4-ol, and if you consider the blue number, it becomes 4 methyl pentan 2-ol. So which one is correct? Here it is written that numbered in such a way that the functional group gets the smallest possible number. Here the functional group is all is the functional group. So here all gets 4th position, here all gets 2nd position. So which one is correct? This one is the correct option, numbering process. So if substituent and the functional group are present, you named or you numbered in such a way that the functional group gets the priority, that is, it gets, the functional group gets the smallest possible number. Okay, like if you consider CH3, CH2, then CH, then CH2, then CH2, then CH3, again it is CH2OH. Now what is the procedure of writing this? So what you have to do? So you take this as a substituent, because if you number, that is 1 2 3 4 5 like this, then in position 1 you get the all alcohol. In any other way, if you try to number, then if you consider this longest chain, this is as a longest chain, then it is become 1 2 3 4 5 6. So it is not possible to give this as a substituent or as a functional group. So always you give the priority if any functional group is present in the carbon chain, then you have to give the utmost priority to the functional group that it gets the smallest possible number of its position. So it becomes, so CH3 and CH2 becomes C2H5, CH3 and CH2, both if you together add this, then it becomes C2H5. So here C2H5 is the substituent, so C2H5 is ethyl, so 2-ethyl. Why it is ethyl? So C2H6 is a ethane, then it loses one hydrogen, it becomes C2H5. So ethane become ethyl if it loses one hydrogen. So 2-ethyl, 1 2 3 4 5 pentan, 1 all. Okay, pentan 1 all, because in the one position the functional group OH is present. Now fifth one, there is the, in case of different types of substituents are attached to the chain, they are arranged and named alphabetically. That is, if the different types of substituents are present, that is, if you take one example, that is the CH3 CH2 CH2 CH3, it is the longest carbon chain. Okay, now here Br is present and here Cl is present. So how can you give the numbering? So first start numbering like this: 1 2 3 4 5 6. Because the longest carbon chain is this, obviously is this, there is no doubt, because it is a straight chain, and you can give the number like this: 1 2 3 4 5 6. Here two substituents are present, one is bromine, second is chlorine. So now if these two substituents are present, then alphabetically which one comes first? B comes first before C, so bromine gets the priority. Arrange name alphabetically, so bromine gets the priority. So if you number like this, then bromine gets 5th position, and if you number if you number from the left side, then bromine gets the 2nd position. So they are arranged and named alphabetically. So bromine is before C, B is before C. It means that bromine is before chlorine, as B comes before C. So this becomes get priority as bromine is 2nd position and chlorine is 4th position. If you consider this number, this numbering system, then why it is wrong? Because for that bromine gets the 5th position and chlorine gets the 3rd position, but here bromine gets priority over chlorine because B comes before C, so bromine gets the smallest number than the chlorine. So it is the name of this is 2-bromo 4-chlorohexane. Single bond is present, that is called hexane. 2-bromo 4-chlorohexane. Now 6th one is The position of alkyl group indicates the writing the position and the name of the alkyl group and the name of the parent hydrocarbon. That is here if you consider CH3, CH2, CH, CH2, CH3, and here CH2, 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 CH3. How you can named? You can named 1, 2, 3, 4, 5, 6, 7. This is the longest carbon chain. You can consider this is the longest carbon chain, 7, or you can consider 1, 2, 3, 4, 5, 6, 7 like this. This is also another longest chain. So for first case, which I have numbered in the red color, here if you consider this path as a longest carbon chain, so the substituent become CH3, CH2, that is the C2H5, that is the ethyl. And if you consider this yellow color numbering, then it is becomes CH2 and CH3, it is also become ethyl. And if you number like this, then in the third position, if you number like this red color, then in third position the substituents come, that is ethyl comes, and if you named like this, number like this, then also the ethyl is becomes present in the third position. So both numbering systems are the right, so it becomes 3 ethyl, 7, that is the heptane. All are the single bond, so that is the N, that is the heptane. Now the last rule is multiple alkyl group are labeled with the Greek numerical prefix such as di for 2, tri for 3 and tetra for 4, penta for 5 and so on. It means there are so many substituents are present, same substituents are present. That is the if C is there, and here it is CH3, then CH2, then CH3, then here it is CH3, and here it is CH3. So here the longest carbon chain, obviously you notice that this one is the longest carbon chain, and you have to number 1, 2, 3, 4 like this. If you number 1, 2, 3, 4 like this, then these two are the substituents that comes in the third position, which is not preferable, because if you number 1, 2, 3, 4 like this, then the two substituents, the CH3 methyl comes in the second position. So you have to prefer this one than this numbering system. So it becomes 2, 2 dimethyl butane. In the second position it is methyl. In the second position, it is another methyl. So 2, 2, so two methyl group are present in the second position. So 2, 2 dimethyl butane. Okay, like this you can take 2 or 3 example. That is, if you consider the simple example 1, CH3, CH, then CH3, then CH3. What is the name of it? You can number in any direction 1, 2, 3, because CH3 is the substituent. If you number like 1, 2, 3, then also substituent is positioned in the second position. So if you write this, then elaborately if you write this word, root is what? The prop, because depending on the number of carbon 1, 2, 3, that is the 3 C3 prop, then suffix suffix is what? Depending on the bond, here all are the single bond, so it is N single bond, that's why it is N. Here prefix comes with the substituent along with its position, so position is 2 and the substituent is methyl. Okay, so position along with the substituent or functional group name. Okay, so the total IUPAC name become what? It is first prefix, pre means first, 2-methyl, then the root word, that is prop, and then suffix N. So 2-methyl is what? It is prefix. Prop is what? It is root word. This N is what? This is suffix. So what is the exact IUPAC? IUPAC, you have to write IUPAC is prefix plus root word plus suffix. This is the exact formation of the IUPAC name. Now take another example, that is the H C C H, then Cl 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 Cl. What is the IUPAC name? So root word, then suffix, then prefix. So root word is what? Root word is 2 carbon are present, 1 and 2, so C2, that is the eth. Suffix is what? Suffix is, all are the single bond, N single bond. What is the substituent? Chloro. What is the position? If number 1 2 or 1 2, whatever it is, in the it is a symmetrical compound, so prefix is 1 1 2 2 tetrachloro. In 1 and 2 there is 2, 1 and 2 chlorine, and again 1 and 2 there is 1 and 2 there are 2 chlorine, so 4 chlorine are there, that's why it is called the 1122 tetrachloro. Okay, so the IUPAC name is 1122, then hyphen, then tetrachloroethane. Okay, this is the IUPAC name. Now take another example, H C C C, then H H H, then in that C there is a O, and here it is a H, another H. Okay, it is not a tough. So here it is C double bond, it is nothing but the keto group, so it exhibits a keto group. Okay, so first write word root. It is, how many carbons are present? 1 2 3, so it is. Then second, suffix. Here the suffix is N. Okay, this is not, this single double bond is not associated with it, as it is nothing but this double bond is comes along with the substituents or the functional group, so it is not associated with the IUPAC names rules. It is another group associate with the hydrocarbon. So in the hydrocarbon, the main hydrocarbon, the bond which is associate are all are the single bond, that's why it is a N. Okay, what is the prefix? That is the, you can write 1 2 3, or you can write 1 2 3. So prefix is comes along with the substituent or the functional group along with its position. So in the second position, what is the functional group? It is the ketone. That is the, for ketone it is the prefix is used is on and the position is 2. So 2-on is the prefix. For keto I have already discussed in the third or fourth video, that is the when I discuss the functional group, that is the when ketone is there, keto group is present, then the prefix uses on, ONE, and here when we write the IUPAC name, we must write down the position of the substituent of the functional group. So that's why here it is the in the second position, that's why I have written at 2-on. So what is the IUPAC name? IUPAC name is propan 2-on. Okay, the common name is, here the common name is, it is nothing but the C double bond O, here CH3, here CH3. This is nothing but the acetone is the common name. So common name is not present in your syllabus. So take another example of it, that is the C H H H, then another C, triple bond C, C H H H. What is the structure look like? There is CH3 C triple bond C CH3. How many carbons are present? 1 2 3 4. 4 carbons are present. So word root is but, then suffix is depending upon the bond, that is the YNE, because triple bond is present, that's why it is a YNE. And the prefix is what? Prefix is nothing but the only 2, because here the substituent or the functional group, whatever you consider, here priority is, here there is no functional group present, so here the substituent is nothing but the double triple bond. I have already discussed in the 4th class that if double bond is there, if there is no substituent like CH3, methyl, ethyl, propyl, butyl, or any other group, that is the alcohol, aldehyde, ketone, or acetic acid, whatever it is. So if there is only single or there is double or triple bond only, then you can write, you can take it as a prefix, that is the, here the position is 2, because you can consider 1 2 3 4, or you can consider 1 2 3 4, whatever you consider, the triple bond is comes after second 2, so prefix is 2. So the IUPAC name is but 2-ine. But 2-ine is the IUPAC name. Hope you get this basic concept of the homologous series and the how can you write the nomenclature. In the next video I can discuss some examples or along with some exercise in the next video. So I can give a short assignment to you to give me the name of the hydrocarbons, the IUPAC name of the hydrocarbons. So in the next video we can start the basic hydrocarbon, that is the alkanes, that is the CnH2n plus 2. What is that alkane? What is the general formula? You know, what is the isomerism of the alkanes, what is the structure of the methane, how methane can be prepared in the laboratory, all these things, what is the property, physical properties, what is the chemical property, what is the substitution reaction of the they can perform, that is the alkane can perform. So that are the very important topic for ICSE, CBSE and West Bengal board and the other board also, because in the if you know the substitution reaction, the properties, the preparation, then if you have a very distinct idea about the organic chemistry which you which you are going to learn in the class 11 and 12 standard chemistry, it is a very difficult. If you don't know about this organic part, then it is very difficult to cope up that things. So hope you understand the videos very well. In the next video we can discuss about the alkanes, and if possible I can discuss some examples also. So hope for the best. So keep watching our video. If possible, then please like, share and subscribe the videos, and please give some comment in which part of and in which subject you are facing the difficulties, as it is a pandemic situation. That's why I am telling this. So keep studying. Today is up to this. See you in the next video. Tata, bye bye.